Greetings everyone. Today we are exploring solving systems by graphing, but this is a very specific video. First and foremost, this is for our Year 1 class because we're breaking it down to when y is solved, when y is already isolated, and you're going to have infinite and many solutions as your answers. So the first thing I want you to do is make sure you're on the right day. Check out the order on my YouTube playlist or check out Google Classroom. A quick review from our previous lesson. A system is just a fancy way to say that you have two equations, possibly more, we're going to stick to two, that are paired together. And our goal is to find the solution. Now, we've had solutions that were perfect ordered pairs. They worked in both equations. But today, this is going to be unique. We're going to have a certain situation that happens, and we're going to talk about what that means. So let's begin with our note sheet. Make sure your example 1 matches mine. You do want the note sheet as we are graphing. We need that graph paper. All right. Remember, I'm going to go pretty quickly through this because we've already spent time on slope-intercept form. If you need those videos, please look back on the YouTube playlist. The first equation, I'm beginning on the y-intercept of positive 2. Remember, B is the y-intercept. Beginning. From that 2, I have a slope, an m, remember m is your slope, of -3. So that means -3/1 is my rise run. So from that dot, we're going to go down 3, negative, run 1. Down 3, run 1. I need a downwards sloping line of 3. All right, and I'm also going to go the other direction a little bit. I know I always say 5 or fill, but I want this to be nice, clear, and specific. All right, let's graph the other lines. So we're graphing 2 lines in each of these lessons. My beginning, my y-intercept is -4. So down 4 is where I'm beginning. Check out that green dot. And my slope is -3 again. Notice how my slopes are the same? That means -3/1. Hold up. Okay, so if I graph this from my green dot, down 3, right 1, down 3, right 1, or if I go the other direction, up 3, left 1. Now my goal was to find where they cross, right? Like we wanted to sink a battleship here. But what do I call these lines when they look like that? Do you remember that word? Parallel. These lines are parallel. Parallel lines are like train tracks, meaning they never cross. So if I asked you, where do these lines cross? Where is their intersection point? We would say never. But it's not okay to say never. We actually have a specific phrase. Do you remember from solving equations what that was called? We have no solution. No solution is what I want to see written on your paper when you have parallel lines. Every single time they're parallel, you write no solution. That's our goal today, is these unique graphs. Let's take a look at example 2. Our beginning is at -6. So -6, 1, 2, 3, 4, 5, 6. Oops, I went too far, I think, didn't I? That's what happens when I use my tablet. 2, 3, 4, 5, 6, right there. All right, there's my beginning. And from there, I have a slope of 2, which means rise 2, run 1, right? 2/1, 2/1, rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. And I'm going to go the other direction. And so I want to try to connect these dots. Possibly if you have a straight edge or the edge of a notebook, you could use that to make your line better. Let's look at our next equation. Well, I have parentheses, right? I could think of this as point slope form, but really, how about we just distribute that 2 in? Because it works out nice and clean. 2 times x is 2x. 2 times 3 is -6. Wait a second. Look at you guys. This is the exact same line. So here's the thing. If I go to begin at -6 and then I count rise 2, run 1, what's going to happen? I have the exact same line, the exact same slope, everything. Everything's the same. So this is unique, right? They don't cross at one point, they cross at every point. That's an interesting situation. So we have a interesting answer. If I asked what is their solution, we say infinite many solutions. Do you remember that answer from solving equations? We've done that before. And so this answer we're still going to use. When it's the same line, it will always be infinite many solutions. Let's try one more. Don't forget we will be graphing horizontal and vertical lines. If it's one letter, one number, slice, remember this is a Mortvet thing, slice the y-axis at 3. Slice the y-axis, which means it's horizontal through 3. And the next one says slice the y-axis at -5. Y-axis, -5, slice it. Perfect horizontal lines, but they never cross. I don't have a nice clean point. They never cross. If they never cross, if they're parallel, remember that? If they're train tracks, there is no solution. They never cross. So today, you're going to be graphing all these lines, and in this particular lesson, we're going to have all no solutions or all infinite many. If you get anything else in this particular lesson, something's wrong, okay? So we're being very specific in our goal today. Make sure you check out Google Classroom to see what the task is at hand. Maybe consider rewatching this video without writing. All right, but we have to remember these are our answers today. Let me know if you have any questions, and until next time, have a good one.